All right, this video is to show you how to solve exponential equations using logarithms. So we have another video on how to solve them by rewriting the bases. And if you haven't watched that video, you should probably do that first, because that's always going to be easiest if that can be performed. Logarithms should be used when you find that you cannot rewrite the bases and solve the equation. So if you've already tried to rewrite the bases and you can't solve the equation, then the steps for using logarithms to solve an equation will be to, number one, isolate the exponential term. So that just means we're going to look for the term where the variable's in the exponent. And so we've got to get everything that's being done to that term to the other side of the equation. Once that's done, then we're going to rewrite the equation in logarithmic form. And once I write it in logarithmic form, I'm going to solve it and write the exact answer or evaluate the answer using a calculator, depending on what the directions of the assignment are. All right, I'm going to show you both here in this video. So let's take a look at a couple examples of equations that we could solve using logarithms. So these are exponential equations because the variable is in the exponent. So as I said, the first step is to isolate the exponential term. So here in number one, the exponential term is the 16 raised to the x plus 7 power. However, that's not isolated because in addition to that term, they are adding 10 to it. So the first thing I would do here is I'd need to come in and I'm going to subtract 10 from both sides. I'm going to subtract 10 from both sides. That's going to eliminate it here on the left. And then I would be left with 16 raised to the x plus 7 power is equal to 12. 22 minus 10 being 12. Now that it's isolated, now I'm going to step down to my second step, and I'm going to rewrite it as a logarithm. So the base of my exponential here is 16. So I'm going to write a logarithm, and it's going to be log base 16. So we got log base 16. The argument for that logarithm is going to be 12. And then the logarithm is always equal to the exponent. So in this case, x plus 7. So now, if I want to get the answer, I need to solve for x. And up above, x has 7 being added to it. So I'm going to subtract 7 from both sides. And so that's going to cancel out the 7s on the right-hand side. On the right-hand side, we're going to be left as equals x, which is what we want. Now, it is tempting because the way I wrote this, and students try this all the time, they want to take the 12 minus the 7. And that's not what we're doing here. So I'm going to move the 7 over. The minus 7 is coming after the logarithm, because the 12 here is the argument to the logarithm. So I can't add or subtract anything from that. So I'm going to write that as log base 16 of 12 minus 7. And this here would be considered our exact answer. All right, this would be the exact answer. So if your assignment asks you to write the exact answer to something, this is what we would write. Now, because our answer involves a logarithm, we know that this thing is going to be irrational. All right? It's going to be irrational unless it happens to be a logarithm that we can easily evaluate, and it comes out to be a whole number. Okay? So that's what we would write for our exact answer. Now, if your assignment says evaluate and round to, say, the 3 decimal places, then what you would need to do is, let's take our calculator. Make it a little bit smaller so I can see the screen. There we go. And so on the calculator, anytime we have a base other than 10, what we need to do is press math, and then you can scroll up. We've got this log base operation here. So I'm going to press enter. It brings back the log. It gives me a place to put in the base and a place for the argument. So I'm going to type 16 in for my base, 12 in for the argument, and then after that, I have to subtract 7 from my logarithm. And so the answer I get here from my calculator is -6, 1.037. So if I was going to round this to, say, 3 decimal places, the 3 would get rounded up to a 4 because of the 7. So here I would say that x is approximately -6.104. Okay, so this is going to be an approximate answer. So it just depends on your assignment, what it asks you for. Okay, this would be an approximate answer. All right, let's take a look at another example. And we're going to, again, write both the exact and an approximate answer to it. So our next example is to solve the equation -8e, which is just Euler's number. It's another base, raised to the -7x plus 2 is equal to -38. Now, when we get into this using the logarithm, it's going to look a little bit different because of our base. But again, the same steps apply. I need to isolate the exponential term, and in this case, the exponential term is this one right here. That's our exponential term. So anything outside that highlighted area, I need to get rid of. So I'm going to start by getting rid of the 2. So I'm going to subtract 2 from both sides. So we're getting rid of those 2's. Those are going to cancel out on the left. -38 minus another 2 will give us -40. And then on the right, that gives us -40. On the left, we're going to be left with -8e, or Euler's number, raised to the -7x. Now, it's still not isolated. I still have the -8 hanging out there. So what I'm going to do now is I'm going to go ahead and divide both sides by -8. And so when I do that on the left, those are going to simplify and essentially become 1. But since e raised to the -7x is being multiplied by 1, it's still there. So I have e raised to the -7x. And -40 divided by -8 will leave us with a +5. Now it comes down to rewriting this thing as a logarithm, and then I'm going to solve for x. Whenever we have a base of e, I could write it a couple of different ways. I could write it as log base e of 5 is equal to -7x, because remember the logarithm is equal to the exponent. Or alternatively, log base e can be replaced with the natural logarithm. And we prefer the natural logarithm because our calculators and most technology have a natural logarithm function on them. Now, notice x has not been solved for here yet. So I've got to come back in and I've got to solve for x, because right now it's being multiplied by -7. So I'm going to divide both sides by -7. And on the right, those are going to simplify out, leaving us with just x over there on the right. And then on the left, nothing can really simplify out, so I'm going to have the natural log of 5 divided by 7, and the negative is going to go out here to the front. Okay. So again, this here would be our exact answer. If you're asked to give an exact answer, this is what you would want to give. Okay. That's your exact answer. However, if you're asked to evaluate and say round to 3 decimal places, that's when you're going to come back to your calculator, and we'll just enter that equation into the calculator, or that expression into the calculator. So here I'm going to press negative. I've got natural log. So there's no need to use the log base when I've got a natural log. And I'm taking the natural log of 5 divided by 7. And I already put the negative in there. And so we get that this is about negative 0.2299. Now, if I'm asked to round this to 3 decimal places, we have to realize that this fourth digit or fourth decimal place is going to round that third decimal place up to basically a 10 or a 0, and we have to bring that 1 forward. So what I would end up with here is that x is approximately equal to negative 0.230. So this is if I was asked to round to 3 decimal places, and again, this would be our approximate answer. It's not going to be exact because a logarithm is irrational, and so its decimal is never going to repeat, and it's never going to stop. So this is an approximate answer. And that's it. So that's how we solve equations using logarithms. 3 basic steps: isolate the exponential term, rewrite it in logarithmic form, solve for the variable, and then write the exact answer or evaluate depending on the instructions for your assignment.